Alright, finally I got it rolling. Solving multi-step equations. Okay, so Monday we talked about just solving a normal equation, a single step, whether we add or subtract. We talked about unwrapping a box with a present in it, that kind of thing. Okay, talked a little bit about doing the reverse of PEMDAS. Okay, so we'll talk about that a little bit more tonight. So if you have, let's just start out with a multi-step equation. It looks like this. Okay, so in this case, if we knew what x was, say we knew x was 2, then what we would do is we would do the multiplication here first, and then do the addition second, and that would give us an answer of 10. Okay? But when you don't know what x is, then what you're going to do is you're going to do the opposite and the reverse of the procedure. So instead of multiplication additions, we're going to do subtractions and divisions. So you're going to reverse it and do the opposite of it. So when solving an equation, 3x plus 4 equals negative 10, since we're reversing it, we're going to subtract the 4 first. That's going to give us a negative 14, and then divide by 3. All right. So we are unwrapping it, right? So we're going to do the exact opposite as we would if we were to wrap the present. We're going to unwrap the present because we don't know what's inside the box. So we're going to subtract 4, divide by 3. All right, that's how you solve a two-step equation. Notice that the equal sign is here. We're trying to keep that balance. You know, I was telling you about Monday, that con video has that nice balance. All right, so what we do to one side of the equation, we have to do to the other side of the equation. Same thing here, where we divide it by 3. Okay, there's my equal sign, so that's my balance tilt. All right. So let's try, we'll try a different one here. 2x plus 1 equals 8. So now, do the same thing. Okay? We're going to get rid of this addition this time first by doing the opposite. All right, so we have 2x equals, that's a 7, divide by 2, x equals 3.5. All right, you can leave your answer as a decimal or as a fraction, doesn't really matter to me. All right, whatever is easy for you. Okay, but the whole idea again, all right, here's our equal sign, so this is our balance. We want to, whatever we do to one side, we have to do to the other. And we're doing the opposite of PEMDAS, or, you know, what you would normally do if you knew what x was. So let's make them just a little bit difficult, more difficult here. So now we have a equation like this. All right. So actually, we could do this in a couple different ways. One way would probably that you see most common would be to distribute that 3 inside, so you can get rid of that. Make sure you distribute it to the 1 also. Okay, now we're ready to solve the equation. So what would we do first? Yeah, minus the 3. Okay, make sure we do it to both sides. The 3's cancel out. That's what we're trying to do. That's what we want to happen. So what do we end up with on this side over on the right side? Negative 11. Okay, all that adding integer stuff I told you, how is you want it to come quick. Okay, so this is an example of that. You don't want to have to use your calculator. You want it to come quick. And then we'll finish it off. Divide by 6. All right, use your calculator to do that. I'm going to think it's like 1.8-ish. Not exactly sure what it is. Okay. Here, all we did, again, distribute that inside there, and then work it out. What we could have done if we wanted to, we could have divided by both sides by 3, and then subtracted 1 and divided by 2. Would have got the same answer. Doesn't make any difference. But most people think that this is the easiest way to do it, so that's why we teach it that way. Okay, so then if we have one like this, same idea. We're going to distribute this through here first. We got a minus and a minus. Okay, so there's our plus 4x. Now what do we do? Add 16. Good. We're seeing that. 4x equals 13. And then divide by 4. As you see, all the ones that I make up hardly ever turn out. Okay. There we go. So when you're doing your test and quiz, you know, they don't turn out, you can say, well, he made them up. So they're probably right. All right. We just distribute it inside. Gives us a negative 16, gives us a plus 4, and we just solve the equation. All right, so we're going to make these, we're making them just progressively a step, a little bit more of a step, a little bit more of a step. Now we have one like this. Again, we have a couple different options we can do because we can distribute this 2 inside, or we can get rid of the 5 first. It doesn't make any difference. You're going to get the right answer. So let's get rid of the 5 first. Because we should do additions before multiplications anyway, since we're doing the opposite of PEMDAS. Okay, now we can distribute that through. And finish solving the equation. Okay. Subtract that 2. Here's another one that's not going to work out. Divide by 4. 3.75. All right. So we added 5 here. Then we just distributed and went from there. We could have distributed and then combined the 5 and the 2. It wouldn't have made any difference. You'd have still got the same answer. All right, it's just a different way of doing it. But if we follow the opposite of PEMDAS, then we would probably do that addition first to get rid of that number. And it's not a bad strategy to try to get rid of it. So you're taking one side, you're simplifying it down, so that you can get it to be a little bit easier to work with. Is there any questions on how we did that one or any of the other ones before we just kick it up a little bit more? Okay, so now here we have one like this. So we have 2 sets of parentheses. We have a number, all right, on the right side. All right, so let's go ahead. Let's distribute this through. Let's distribute this one through. So what would we get right here?
Negative 6 plus
Negative 6x, good, plus
3
3, good, plus
plus 20x
20x, good,
minus 6. Oh, minus 24.
good, equals 24, right?
Yeah.
Okay. All right, cool. So we got that. Okay, now we want to combine terms that are like to make this equation just a little bit more simpler. All right, so let's look at this. So we have a 3 here. We have a 24 here. So what's that going to give us?
Negative 21.
Negative 21, good. We have a negative 6 here and a positive 20. Notice that I'm including the sign so I know what to do with them. So I know I have negative 6 and I know I have a plus 20. Okay, so I'm including that. So what does that give us? 14x, good. Equals 24. So now all of a sudden we've taken a pretty complex equation actually here, and we've got it down to where it's simple and we can do it because it's just a two-step and we're good at those now. We can do those. So we'll add 21. For a minute there I thought this one was going to actually turn out. 45. And then I got to divide by 14. I don't know what that is. 2, 3 something. 3.3? 2? Okay. And if if you have some decimals, rounding to the 10th is fine. That's a good kind of rule of thumb. But the idea here is we took this one, okay, a rather complex solving equation, first multi-step one, distributed and just kind of combined the like terms, okay, and worked it out. Now, you could start moving things over at that point if you want to. Okay, you could have added 24, we could have subtracted 3. Again, we would have got the same thing. All right, but I think it's a best rule is to combine your like terms first and then move things over. All right. It is amazing how many people will make this little mistake here. Let me get to a different color here. I'll use this gold. Oh, I guess I already used it. I don't want to use gold. I'll use this brown. And what they would do is they would add 24 here and add 24 here. Okay? Because they're so used to doing the opposite, they think that's what they should do, but we don't want to do that. Okay? If you're going to add 24, you got to add it over to the other side of that equal sign right there. That's my balance. Okay? Here you're combining like terms. So there's a difference between combining like terms and moving things around. It's a very common mistake for that to happen, so be careful on that. All right, let's take a look at, one like this. Okay, so I'm going to look at this one graphically. So this is where we might use some of the app on our phones here. So what we're going to do is distribute this through. Add a 3 like we know how to do. Notice how this one turns out. Okay. Now one way to look at this in a graphic sense, and even though we haven't done any graphing, you don't really know how to do any graphing to do this part. All right, so what I'm going to do is just kind of minimize this and go into internet. So if you have a phone and you want to follow along, this would be great. If you don't, that's up against it. Oh, that's right, I can't do it this way. Sorry. Let me do it this way instead. There we go. The little app we're going to use is called DESMOS, called Desmos. It's a free graphing calculator. It's kind of a cool little thing. You can use it on your phone. A lot of my kids at school do this. They use this. I guess I should just use the calculator thing. So it looks kind of like this. All right. So what I'm going to do is put in my equation that I just did. So I'm going to put here, I'm going to put 3 parentheses 2x. I'm just typing this stuff right off the computer here. 1 parentheses. So I'm going to put that right there. So that's one part of it. Then I'm going to click down here. All right, and now I'm going to put in 9 because that was the other part of the equation. So it was 3 times, it was like this. This is what we had. so this is the balance. So we're going to put in this side, and we're going to put in that side. All right, I'm going to press enter. Okay, now I don't see the 9, but if I scroll, and you can, use whatever that terminology is. Where's the 9 at? Why isn't it working? Oh, maybe I have to put y equals 9 because it probably doesn't understand that. Y equals 9, there it is. Right here is the answer. If I click on that, it says it's 2. And 2 is the answer to the equation, to the problem. Okay, so what's happening here is we're taking this expression here and we're graphing it, and this 9 and we're graphing it, and where they intersect is the answer. Okay, so it's a visual way of finding the answer to solving an equation. Right? So we can solve any of these equations by using this. You can check your answers if you want by graphically taking a look at it. So let's look at it. So let's jump down here. Let's do another one. I don't want to toggle back and forth. I'll just do it up here. All right. So let's take a look at a different one. Let's say we have 4. Let's go with 8 minus 3x parentheses plus 4 equals. Let's go with a negative 12. Okay. I'm not even going to do anything with this. I'm just going to take and put this into one side of the equation and that into the other side. So I'm going to come back up. If I'm using this on my phone here, okay, I'm going to delete this stuff out. Here's a little delete right here. Deletes it for you. Now I'm going to take and I'm just going to type this part in first. Not even simplifying anything. I'm just going to let the computer do the work for me here. 4 parentheses 8 minus 3x, okay, plus 4. All right, then I'm going to come down here and put in negative 12 because I don't, right there, there's the other side. Okay, now I don't see it, but that's because negative 12 is down here, and I can minimize this a little bit. I can kind of do whatever this is called. There's the negative 12. So here's the negative 12 line. Here's the equation line right there where they intersect. That's the answer. It says it's 4. Wow, another one that works out. Let's see if it's actually 4. Okay. So what would we do first to this one to figure this one out? What could we do first? Minus the 4. Okay, then what are we going to do?
Transfer the 4 times 8 is 32, and then 4 times 3 is 12.
Okay, good, Eric. Now what would we do here?
Now you subtract 32.
That's good. We're going to subtract 32 because this is 32 minus 12. The minus goes with the 12. When you read this, 32 minus 12, the minus is going with the 12. Okay, 32 is positive. So we get a negative 12x equals
48.
negative 48.
And then 48 divided by 12 is 4.
There we go. So it works. Okay. So kind of a slick little tool, all right, as far as how to check your answer and how to visually see these equations being solved. All right.
Is that an x variable and a y variable at the intersection?
Yeah, it is. It's an x variable and a y variable. So the x variable is the answer, and the y variable is what it's equal to when you put.
Yeah, we already got
right
that
there.
variable,
Yeah.
so we're just checking the
Right.
the x. Okay.
Okay. All right. So let's pop back to this for a second here. There it is. All right. So again, let's solve some multi-step equations. But now, what would happen if we put, and we did something like this, where we have an x on both sides? We addressed this a little bit on Monday. Okay, but we're going to talk about it now, and this is just a tad bit different. All right, and then we'll take a look at it graphically. All right. So in this case, what are we going to do to both sides here? Yeah, we're going to take the 3x and subtract it to both sides. Who said this should do that? Was that Green? Okay. How come we didn't pick 9?
Well, it's better if you subtract the smallest one.
That's right. We want to pick the smallest one, right? Instead of choosing 9, we could have. But if we pick 9, then we're going to get some negatives, right? We could make a mistake there, so we're going to pick the smallest one. Okay. Either you knew that or you learned that on Monday. Because I mentioned that, right? We probably knew it. Yeah, I'm not that good that you would have. Yeah. Okay, there we go. All right, so now what are we going to do? Add 10 to both sides, yeah. I'm on a roll. This one's working out too. So x turns out to be 3. All right. So when we have variables on both sides, then what we want to do is make sure that, again, here's my equal sign. I'm putting all the variables on this side. This is the side I'm going to put my x on. This is the side where I'm going to put my numbers on. All right? And it doesn't matter which side of that equal sign I decide to do that. I just want to make sure I have them on opposite sides. It's that balance thing. It's that whole balance. Okay. If we look at that using the graph, so we're going to be back here. All right, this time what I'm going to do is I'm going to put the 1/2, which was the 3x plus 8, I think it was. So that's going to be on one side. And what was this one? 6x?
9x minus 10.
9x minus
10.
10? That's what it was? Okay. So now what I'm going to do is put the left and the right half both in. So here, I'm going to go 3x plus 8. So I'm going to put that right down in here. I'm going to put in the other half. All right. So now I have a red line and a blue. All right. And if I scroll up here, here's where they're going to intersect. I'm going to click on that. And it says 3 and 17. What did I get for an answer? We got 3. How about that? So see, it's a nice way to visually see what's going on. Okay? And it's a free little app. Okay, I'm going to go back to this. All right, let's try a couple other ones here. I want to take a look at, and then I'm going to turn you loose on some problems. Although we might do it a little differently tonight. 3x, let's go over 8 minus 4 equals negative 12, something like that. Okay, so then we have 3x minus 4 equals negative 12. Okay, I have a fraction here. Uh-oh, you know, we already don't like fractions too well. But let's work with it. So what should we do first? Yeah, let's add the 4. Doesn't change anything just because we have a fraction there. Get out. 3x over 8 equals negative 8. Good. All right, now we talked about this on Monday. Here's a one-step equation now. We talked about the different ways of solving this. All right, I don't know how many people got to this part here on their assignment. So what should we, what's one thing we could do here to get the answer?
Multiply it.
We could multiply it by
8.
8, right?
Yeah.
8 would be good. What else could we do? We could multiply by 8/3, right? Okay, so we could multiply by 8. That would be certainly a good answer. We could multiply by 8/3. All right, what's another thing we could do? Now, what if it was just 3x? What would you do to both sides? What if it was just 3x? What would we do?
Divide.
We divide. So we can still do this. Okay? The procedure doesn't change. All right? You can still say, hey, I'm just going to divide by 3/8. All right? If I divide by 3/8, then I know I'm going to have negative 8 divided by 3/8. But that's the same thing as taking negative 8 and doing what with this? Times 8/3, right? Hey, that's one of the things we said we could do in the first place. All right? So, see, it's the same thing. You just got to decide what you want to do. This turns out, oh, there goes my streak. Negative 64/3. All right? And again, decimal fraction doesn't matter how you want to do it. All right? So if we have this again, just to repeat it, maybe. All right, I could multiply by 8/3. Same idea. You can see it's going to get you the same answer. All right, these are just going to cross out. Darlene says, well, what if I multiply by 8? Good idea. 8s are going to cross, right? 3x equals negative 64. And now I can just divide by 3. So either way we do it, okay, we're going to get the right answer. You just got to find a way that you're comfortable in dealing with that problem. All right, whether it be dividing straight up, multiplying by 8, or multiplying by 8/3, whatever way you want to do it. Just got to find that way. But that's how you handle one with a fraction. All right. Let's look at one like this. Okay, so now let's say we have one kind of like this. All right. So, lots of little more fraction stuff. What should we do here first? That's a great idea. Let's add 1. Okay. So I'm going to have x plus 3 over 4 equals x plus 3. Okay. Now, one thing we could do here is if we think about this a little bit, we have this division. All right. So what should we do to get rid of that division? Yeah, let's times everything by 4. That's a great idea. All right? Because then that it's going to clear that 4 out of there. Okay, so that's going to go. Now make sure that you go all the way across when you multiply. So what is this side going to be left with if we multiply by 4? X plus 3 equals, what are we going to get on this side? 4x plus 12, right? Okay, now here we go. We kind of got it a little bit simpler. How are we going to solve this one? What should we do now? Okay. See here, you're subtracting the number first. Again, it doesn't matter. Last time we moved the variable first. Now we're moving the number first, but it doesn't make any difference. But this next step is crucial. What are we going to do now?
Get the like terms together.
That's right. So which one's moving?
Want the x by itself. Oh no, the 4. The 4.
We got to move the 4 because here's that balance, right? My numbers on this side, I got to put the x's on that side. Unfortunately, this time I'm going to have to deal with some negatives, but that's okay. We'll just have to deal with it. And then we divide by negative 3. Okay? Now that was a lot. We did a lot of stuff there. Okay, we started out, we took one step, we multiplied by 4. Okay? We did a lot of stuff there. And we could have, right here in the very beginning, we can put that in the Desmos and it will figure it out for you. Okay? It will do it. We could have got the same answer. All right? Okay. So, how many of you are able to access that little app right now? If you did it right now, could you do it? Could you access it? You got it. Good. You got it. Good. DESMOS. No. Ah. Yes.
No connection.
No connection. Okay. Well, that ruins what I was going to do. All right. That's okay. We'll do it this way. So what I want to do is kind of shake it up a little bit here. I'm going to give you a couple of problems I want you to take a look at.